Assalamu alaikum everyone, I hope you're all doing great. Today we will be discussing the scheme of work of Cambridge O-Levels Physics 5054. To start off, let me introduce you guys to the topics. Number 1, motion, forces and energy. Number 2, thermal physics. Number 3, waves. Number 4, electricity and magnetism. Number 5, nuclear physics. Number 6, space physics. For each specific topic, we will be discussing its learning objectives, which are basically the further out points in a specific topics that every student needs to cover in order to cover their entire syllabus. 1. Motion, forces, and energy. Key concept 1.1.1 Physical quantities and measurement techniques. Learning objectives. Describe how to measure a variety of lengths with appropriate precision using tapes, rulers, and micrometers, including reading the scale on an analog micrometer. Describe how to use measuring cylinder to measure the volume of a liquid or finding the volume of a solid by displacement. Describe how to measure a variety of time intervals using clocks and digital timers. Determine an average value for a small distance and for a small interval of time by measuring multiples, including the period of oscillation of a pendulum. Key concept 1.1.5 Physical quantities and measurement techniques. Learning objectives. Understand that a scalar quantity has magnitude size only and that a vector quantity has magnitude and direction. Note that the following quantities are scalar: distance, speed, time, mass, energy, and temperature. Note that the following quantities are vectors: displacement, force, weight, velocity, acceleration, momentum, electric field strength, and gravitational field strength. Determine by calculation or graphically the resultant of two vectors at right angle. Key concept 1.2.1 Motion. Learning objectives. Define speed as distance traveled per unit time and define velocity as change in displacement per unit time. Recall and use the equation speed is equals to distance upon time, or v is equals to s upon t. Recall and use the equation average speed is equals to total distance traveled upon total time taken. Define acceleration as change in velocity per unit time. Recall and use the equation acceleration is equals to change in velocity per unit time, or E is equals to change in v upon change in time. Describe what is meant by and describe examples of uniform acceleration and non-uniform acceleration. Note that a deceleration is a negative acceleration and use this in calculations. Key concept 1.2.7 Motion. Learning objectives. Sketch, plot, and interpret distance time and speed time graphs. Determine from the shape of a distance time graph where an object is A. At rest, B. Moving with constant speed, C. Accelerating, D. Decelerating. Calculate speed from the gradient of a distance time graph. Key concept 1.2.9 Motion. Learning objectives. Determine from the shape of a speed time graph when an object is at A. Rest, B. Moving with constant speed, C. Moving with constant acceleration, D. Moving with changing acceleration. Calculate the area under a speed time graph to determine the distance traveled for motion with constant speed or constant acceleration. Calculate acceleration from the gradient of a speed time graph. Key concept 1.2.10 Motion. Learning objectives. State that the acceleration of free fall g for an object near to the surface of Earth is approximately constant and is approximately 9.8 meters per second squared. State that the mass is a measure of the quantity of matter in an object at rest relative to the observer. State that the mass of an object resists change from its state of rest or motion, which is known as inertia. Note that weights, and therefore masses, may be compared using a beam balance or equal arm balance. Describe how to determine mass using an electronic balance. Describe how to measure weight during a force meter. Define gravitational field strength as force per unit mass. Recall and use the equation. Gravitational field strength is equals to weight upon mass, or G is equals to W upon M. And know that this is equivalent to the acceleration of free fall. State that a gravitational field is a region in which a mass experiences a force due to gravitational attraction. Key concept 1.4.1 Density. Learning objectives. Define density as mass per unit volume, recall, and use the equation D is equals to m upon v. Describe how to determine the density of a liquid, of a regularly shaped solid, and of an irregularly shaped solid, which sinks in liquid volume by displacement, including appropriate calculations. Key concept 1.5.1.1 Balanced and unbalanced forces. Learning objectives. Identify and use different types of forces, including weight, gravitational force, friction, drag, air resistance, tension, elastic force, electrostatic force, magnetic force, thrust, driving force, and contact force. Identify forces acting on an object and draw free body diagrams representing the forces. State Newton's first law as an object either remains at rest or continues to move in a straight line at constant speed until acted on by a resultant force. State that a force may change the velocity of an object by changing its direction of motion or its speed. Determine that the resultant of two or more forces acting along the straight line. Key concept 1.5.1.6 Balanced and unbalanced forces. Learning objectives. Recall and use the equation. Resultant force is equals to mass into acceleration, or F is equals to ma. State Newton's third law. When object A exerts a force on object B, then object B exerts an equal and opposite force on object A. Note that Newton's third law describes pair of forces of the same type acting on different objects. Key concept friction. Learning objectives. Describe friction as a force that may impede motion and produce heating. Understand that motion of objects acted on by a constant weight or driving force with and without drag, including air resistance or resistance in a liquid. Explain how an object reaches terminal velocity. Key concept 1.5.2.4 Friction. Learning objectives. Define the thinking distance, braking distance, and stopping distance of a moving vehicle. Explain the factors that affect thinking and braking distance, including speed, tiredness, alcohol, drugs, tire, surface, and road conditions. Learning objectives 1.5.3.1 Elastic deformation. Learning objectives. Know that the forces may produce a change in size and shape of an object. Define the spring constant as force per unit extension. Recall and use the equation. Spring constant is equals to force upon expansion, or K is equals to F upon X. Sketch, plot, and interpret load extension graphs for an elastic solid and describe the associated experimental procedures. Define and use the term limit of proportionality for a load extension graph and identify this point in the graph. An understanding of the elastic limit is not required. Key concept 1.5.6.1 Center of gravity. Learning objectives. State what is meant by center of gravity. Describe how to determine the position of center of gravity of a plane lamina using a plumb line. Describe quantitatively the effect of the position of a center of gravity on the stability of simple objects. Key concept 1.5.5.1 Turning effect of forces. Learning objectives. Describe the moment of force as a unit of its turning point effects and give everyday examples. Define the moment of a force as moment is equals to force into perpendicular distance from the pivot. Recall and use this equation. State and use the principles of moment for an object in equilibrium. Describe an experiment to verify the principle of moments. Key concept 1.5.4.1 Circular motions. Describe quantitatively motion in a circular path due to a force perpendicular to the motion as A. Speed increases if force increases with mass and radius constant. B. Radius decreases if force increases with mass and speed constant. C. An increased mass requires an increased force to keep speed and radius constant. F is equals to mv upon r is not required. Key concept 1.6.1 Momentum. Learning objectives. Define momentum as mass into velocity. Recall and use the equation P is equals to mv. Define impulse as force into time, for which force acts. Recall and use the equation. Impulse is equals to F into change into T is equals to change into mv, which is change in momentum. Apply the principle of conservation of momentum to solve simple problems in one dimension. Define resultant force as a change in momentum per unit time. Recall and use the equation. Resultant force is equals to change in momentum upon time taken. F is equals to change in P upon change in T. Key concept 1.7.1.1 Energy, Work, and Power. Learning objectives. State that energy may be stored as kinetic gravitational potential, elastic strain, nuclear electrostatic, and internal thermal. Describe how energy is transferred between stores during events and processes, including examples of transfer by force, mechanical working, electrical currents, electrical working, heating, and by electromagnetic sound and other waves. Know that the principle of conservation of energy and apply this principle to the transfer of energy between stores during events and processes. Key concept 1.7.2.1 Work. Learning objectives. Recall and use this equation. Work done is equals to force into distance moved in the direction of the force. W is equals to Fd. 1.7.1.4 Energy. Learning objectives. Recall and use the equation for kinetic energy. E is equals to half mv squared. Recall and use the equation for the change in gravitational potential energy. E is equals to mgh. Key concept 1.7.3.1 Energy resources. Learning objectives. List renewable and non-renewable energy sources. Describe how useful energy may be obtained or electrical power generated from A. Chemical energy stored in fossil fuels. B. Chemical energy stored in biofuels. C. Hydroelectric resources. D. Solar radiation. E. Nuclear fuel. F. Geothermal resources. G. Wind. H. Tides. I. Waves in the sea, including references to a boiler, turbine, and generator where they are used. Describe advantages and disadvantages of each method limited to whether it is renewable, when and whether it is available, and its impact on the environment. Key concept 1.7.5.1 Power. 1.7.4.1 Efficiency. Learning objectives. Define power as work done per unit time and also as energy transferred per unit time. Recall and use the equations. Power is equals to work done upon time, or P is equals to W upon T, and power is equals to energy transferred upon time taken. P is equals to E upon T. Define efficiency as percentage. Efficiency is equals to used energy output upon total energy input multiplied by 100. B. Percentage. Efficiency is equals to useful energy output upon total energy or power input multiplied by 100. Recall and use these equations. Key concept 1.8.1 Pressure. Learning objectives. Define pressure as force per unit area. Recall and use the equation. Pressure is equals to force upon area, or P is equals to F upon A. Describe how pressure varies with force and area in concept to everyday examples. Key concept 1.8.3 Pressure. Learning objectives. State that the pressure at a surface produces a force in a direction at right angles to the surface, and describe an experiment to show this. 1.8.4 Describe how the height of a liquid column in a liquid barometer may be used to determine the atmospheric pressure. Describe quantitatively how the pressure beneath the surface of a liquid changes when depth and density of the liquid. Recall and use the equation for change in pressure beneath the surface of a liquid. Change in pressure is equals to density into gravitational field strength into change in height, or change in P is equals to rho GH. Number 2. Thermal physics. Key concept 2.1.1.1 States of matter. Learning objectives. Know the distinguishing properties of solids, liquids, and gases. Know the terms for the changes in state between solids, liquids, and gases. Gas to solid, solid to gas, transfers are not required. Key concept 2.1.2.1 Particle model. Learning objectives. Describe quantitatively the particle structure of solid, liquid, and gases, relating their properties to the forces and distance between the particles to the motion of the particles, atoms, molecules, ions, and electrons. Describe the relationship between the motion of molecule and temperature, including the idea that there is a lowest possible temperature, minus 273 degrees Celsius, also known as absolute zero, where the molecules have the least kinetic energy. Describe the pressure and changes in pressure of a gas in terms of the forces exerted by particle colliding with surface, creating a force per unit area. Key concept 2.2.1.1 Thermal expansion of solids, liquids, and gases. Learning objectives. Explain applications and consequences of thermal expansion in concept of common examples, including the liquid and glass thermometer. Explain in terms of motion and arrangement of atoms and molecules the thermal expansion of solids, liquids, and gases, and state the relative order of magnitudes of the expansion of solids, liquids, and gases. Key concept 2.1.2.4 Particle model. Learning objectives. Explain quantitatively in terms of particles the relationship between A. Pressure and temperature at constant volume, B. Volume and temperature at constant pressure, C. Pressure and volume at constant temperature. Recall and use the equation P1V1 is equals to P2V2, including a graphical representation of the relationship between the pressure and volume of a gas at constant temperature. Key concept 2.2.2.1 Specific heat capacity. Learning objectives. Know that an increase in temperature of an object increases its internal energy. Define specific heat capacity as the energy required per unit mass per unit temperature increase. Recall and use the equation. Specific heat capacity is equals to change in energy upon mass into change in temperature. C is equals to EM upon change in theta. Describe experiments to measure the specific heat capacity of a solid and of a liquid. Key concept Specific heat capacity. Learning objectives. Describe an increase in temperature of an object in terms of increase in the average kinetic energies of all the particles in the object. Key concept 2.2.3.1 Melting, boiling, and evaporation. Learning objectives. Describe melting, solidification, boiling, and condensation in terms of energy transfer without a change in temperature. Know that melting and boiling temperatures for water at standard atmospheric pressure. Describe the differences between boiling and evaporation. Describe evaporation in terms of the escape of more energetic molecules from the surface of the liquid. Describe how temperature, surface area, and air movement over a surface affect evaporation. Explain how evaporation causes cooling. Describe latent heat as the energy required to change the state of a substance and explain in terms of particle behavior and the forces between particles. Key concept 2.3.1.1 Conduction. Describe experiments to distinguish between good and bad thermal conductors. Describe thermal conduction in all solids in terms of atomic or molecular lattice vibrations, and also in terms of the movements of free delocalized electrons and magnetic conductors. Key concept 2.3.2.1 Convection. Learning objectives. Explain convection in liquids and gases in terms of density changes and describe experiments to illustrate convection. Key concept 2.3.3.1 Radiation. Learning objectives. Describe the process of thermal energy transfer by infrared radiation and note that it does not require a medium. Describe the effect of surface color, effect of black or white, and texture, dull or shiny, on the emission, absorption, and reflection of infrared radiation. Describe how the rate of emission of radiation depends on the surface of temperature and surface area of object. Describe experiments to distinguish between good and bad emitters of infrared radiation. Describe experiments to distinguish between good and bad absorbers of infrared radiation. Key concept 2.3.4.1 Consequences of thermal energy transfer. Learning objectives. Explain everyday applications using ideas about conduction, convection, and radiation, including A. Heating objects such as kitchen pans. B. Heating a room by convection. C. Measuring temperature using an infrared thermometer. D. Using thermal insulation to maintain the temperature of a liquid and to reduce thermal energy buildup transfer in buildings. Number 3. Waves. Key topics 3.1.1 General properties of waves. Learning objectives. Know that waves transfer energy without transferring matter. Describe what is meant by wave motion as illustrated by vibrations in ropes and springs and by experiments using water waves. Describes the features of a wave in terms of wavefront, wavelength, frequency, crest, trough, amplitude, and wave speed. Define the terms. A. Frequency as a number of wavelengths that pass a point per unit time. B. Wavelength as the distance between two consecutive identical points, such as two consecutive crests. C. Amplitude as the maximum distance from the mean position. Recall and use the equation. Wave speed is equals to frequency into wavelength, or V is equals to F lambda. Note that for a transverse wave, the direction of vibration is right angles to the direction of energy transfer, and give examples such as electromagnetic radiation, waves on the surface of the water, and seismic S waves. Note that for a longitudinal wave, the direction of vibration is parallel to the direction of transfer of the energy, and give examples such as sound wave and seismic P waves. Describe how waves can undergo reflection at a plane surface. B. Refraction due to change of speed. C. Diffraction through a gap. Describe how wavelength and gap size affect diffraction through a gap. Describe the use of a ripple tank to show A. Reflection at a plane surface. B. Reflection due to change in speed caused by a change in depth. C. Diffraction due to a gap. D. Diffraction due to an edge. Describe how wavelength affect diffraction at an edge. Key concept 3.2.1.1 Reflection of light. Learning objectives. Define and use the term normal, angle of incidence, and angle of reflection. Describe an experiment to illustrate the law of reflection. Describe an experiment to find the position and characteristics of an optical image formed by a plane mirror, same size, same distance from the mirror as object and virtual. State that for reflection, the angle of incidence is equal to angle of reflection and use this in constructions, measurements, and calculations. Key concept 3.2.2.1 Refraction of light. Define and use the terms normal, angle of incidence, and angle of refraction. Define refractive index, n as in n equals to sine 1 upon sine r. Recall and use this equation. Describe an experiment to show refraction of light through glass blocks of different shapes. Define the term critical angle and total internal reflection. Recall and use the equation. N is equals to 1 upon sine 3. Describe experiments to show internal reflection and total internal reflection. Describe the use of optical fibers, particularly in telecommunications, stating the advantages of their use in each context. Key concept 3.2.3.1 Thin lenses. Learning objectives. Describe the action of thin converging and thin diverging lens on a parallel beam of light. Define and use the terms focal length, principal axis, and principal focus. Draw ray diagrams to illustrate the formation of real and virtual images of an object by converging lens, and note that a real image is formed by converging rays and that a virtual image is formed by diverging rays. Define linear magnetization as a ratio of image length to optic length. Recall and use equation. Linear magnification is equals to image length upon object length. Describe the use of a single lens as a magnifying glass. Draw ray diagrams to show the formation of images in the normal eye, a short-sighted eye, and a long-sighted eye. Describe the use of converging diverging lenses to correct long-sightedness and short-sightedness. Key concept, dispersion of light. Key learning objectives. Describe the dispersion of light as illustrated by refraction of white light by a glass prism. Note the traditional 7 colors of the visible spectrum in order of the frequency and in order of wavelength. Key concept, electromagnetic spectrum. Learning objectives. Know the main regions of electromagnetic spectrum in order to frequency and in order of the wavelength. Note that the speed of all electromagnetic waves in A vacuum is 3 into 10 to the power 8 meters per second. B, air is approximately the same as in a vacuum. Describe the role of the following components in the stated applications. A. Radio waves, radio and television communications, astronomy, microwaves. satellite television, mobile cell phone, Bluetooth, mobile ovens. C. Infrared, household electrical appliances, remote controllers, intruder alarms, thermal imaging, optical fibers. D. Visible light, photography, vision. E. Ultraviolet, security marketing, detecting counterfeit banknotes, sterilizing water. X-rays, hospital, used in medical imaging, security scanners, killing cancerous cells, engineering applications such as detecting cracks in metals. Gamma rays, medical treatment in detecting and killing cancerous cells, sterilizing food and medical equipment, engineering applications such as detecting cracks in metals. Describe the damage caused by electromagnetic radiations, including A. Excessive exposure causing heat of soft tissues and burns. B. Ionizing effects caused by ultraviolet, skin cancer and cataracts. X-rays and gamma rays causes cell mutation and cancer. Key concept 3.4.1 Sound. Learning objectives. Describe the production of sound by vibrating sources. Describe the longitudinal nature of sound waves and describe compressions and refractions. State the approximate range of frequencies audible to humans as 20 Hz to 20,000 Hz. Explain why sound waves cannot travel in a vacuum and describe an experiment to demonstrate this. Describe how changes in amplitude and frequency affect the loudness and pitch of sound waves. Describe how different sound sources produce sound waves with different quantities, timbres, as shown by the shape of the traces on an oscilloscope. Key concept 3.4.12 Sound. Learning objectives. Define ultrasound as sound with a frequency higher than 20 kHz. Describe the uses of ultrasound in cleaning, prenatal and other medical scanning, and in sonar, including calculation of depth or distance from time or wave speed. Describe an echo as a reflection of sound waves. Describe simple experiments to show the reflection of sound waves. Describe a method involving a measurement of distance and time for determining the speed of sound in air. Note that the speed of sound in air is approximately 330 to 350 meters per second. Note that in general, sound travels faster in solids than in liquids and faster in liquids than in gases. Number 4. Electricity and magnetism. Key concept 4.1.1 Simple magnetism and magnetic fields. Learning objectives. Describe the forces between magnetic poles and between magnets and magnetic materials, including the use of the terms North Pole, South Pole, attraction and repulsion, magnetized and unmagnetized. Describe induced magnetism. State the difference between magnetic and non-magnetic materials. Key concept 4.1.5 Simple magnetism and magnetic fields. Learning objectives. Describe a magnetic field as a region in which a magnetic pole experiences a force. Describe the plotting of magnetic field lines with the compass or iron fillings and use of a compass to determine the direction of magnetic field. Draw the pattern and direction of the magnetic field lines around a bar magnet. State that the direction of magnetic field at a point is the direction of the force on the end pole of a magnet at that point. Know that the relative strength of a magnetic field is represented by the spacing of the magnetic field lines. Key concept 4.1.4 Simple magnetism and magnetic fields. Learning objectives. State the differences between the properties of temporary magnets, which are made of soft iron, and permanent magnets, made of steel. Describe uses of permanent magnets and electromagnets. Key concept 4.2.1.1 Electric charge. Learning objectives. State that there are positive and negative charges and that charge is measured in coulombs. State that unlike charges attract and like charges repel. Describe experiments to show electrostatic charging by friction. Explain that charging of solids by friction involves only a transfer of negative charges, which are electrons. Key concept Electric charge. Learning objectives. Describe an electric field as a region in which a charge experiences a force. State that the direction of an electric field line at a point is the direction of the force on a positive charge at that point. Describe simple electric field patterns, including the field A around a point charge, B around a charged conducting sphere, C between two oppositely charged parallels conducting plates. N effects will not be examined. Key concept 4.2.1.8 Electric charge. and electrical current. Learning objectives. State examples of electrical conductors and insulators. Describe an experiment to distinguish between electrical conductors and insulators. Recall and use a simple electron model to explain the differences between electrical conductors and insulators. Describe electrical conduction in metals in terms of movements of free ions. Key concept 4.2.2.1 Electrical current. Learning objectives. Define electric current as a charge passing a point per unit time. Recall and use the equation. Electric current is equal to charge upon time. I is equal to Q upon T. Know that current is measured in amperes, and that the amp is given by coulombs per second, C upon S. Know the difference between direct current and alternating current, or DC and AC. State that conventional current is from positive to negative and that the flow of electrons is from negative to positive. Describe the use of ammeters, analog and digital, with different ranges. Key concept: series and parallel circuits. Learning objectives. Recall and use in calculations the fact that A. The current at every point in series circuit is the same. B. The sum of currents into the junction in a parallel circuit is equal to the sum of currents that leave the junction. Key concept: electromotive force and potential difference. Learning objective. Define EMF, electromotive force, as the electrical work done by a source in moving a unit charge around a complete circuit. Recall and use the equation. EMF is equal to work done by a source upon charge, or E is equal to W upon Q. Define PD, or potential difference, as the work done by a unit charge passing through a component. Recall and use. PD is equal to work done on a component upon charge, or V is equal to W upon Q. Know that EMF and PD are measured in volts, and that the volt is given by joule per coulomb, or G upon C. Describe the use of voltmeters, analog and digital, with different ranges. Calculate the total EMF where several sources are arranged in series. State that EMF of identical sources connected in parallels is equal to the EMF of one of the sources. Key concept: series and parallel circuits. Learning objectives. Recall and use in calculation the fact that total dP across the components in a series circuit is equivalent to the sum of the individual potential differences across the components. B. The PD across an arrangement of parallel resistors is same as the PD across one branch in the arrangement of the parallel resistances. 4.2.4.1 Resistance. Learning objectives. Recall and use the equation. Resistance is equals to PD upon current, or R is equals to W upon I. Describe an experiment to determine resistance using a voltmeter and an ammeter, and do the appropriate calculations. Recall and use for a wire the direct proportionality between resistance and length and inverse proportionality between resistance and cross-sectional area. State Ohm's law including reference to the constant temperature. Sketch and explain the different current voltage graphs for a resistor of constant resistance, a filament lamp, and a diode. Describe the effect of temperature increase on the resistor of a resistor, such as the filament in a filament lamp. Key concept 4.3.1.1 Circuit diagrams and circuit components. Learning objectives. Draw and interpret circuit diagrams with cells, batteries, power supplies, generator, oscilloscopes, potential dividers, switches, resistors, heaters, thermistors, light-dependent resistors, lamps, motors, ammeters, voltmeters, magnetizing coils, transformers, fuses, relays, diodes, and light-emitting diodes, and know how these components behave in a circuit. Key concept: series and parallel circuits. Learning objectives. Calculate the combined resistance of two or more resistors in series. Calculate the combined resistance of two resistors in parallel. Calculate current, voltage, and resistance in parts of circuits or in the whole circuits. Key concept 4.3.3.1 Action and use of circuit components. Learning objectives. Describe the action of negative temperature coefficient NTC thermistors and light-dependent resistors and explain the use as input sensors. Describe the action of a variable potential divider. Recall and use the equation for two resistors used as a potential divider. R1 upon 21 upon R2 is equals to V1 upon V2. Key concept 4.4.1.1 Uses of electricity. Learning objectives. State common uses of electricity, including heating, lighting, battery charging, power motors, and electronic systems. State the advantages of connecting lamps in parallel in a lighting circuit. Recall and use the equation. Power is equals to current into voltage, or P is equals to IV. Recall and use the equation. Energy is equals to current into voltage into time, or E is equals to I into V into T. Define the kilowatt hour, kWh, and calculate the cost of electrical appliances with the energy unit is a kWh. Key concept, electrical safety. Learning objectives. State the hazards of A. Damaged insulation, B. Overheating cables, C. Damp conditions, D. Overloading of plugs, extension leads, single and multiple sockets when using a main supply. Explain the use and operation of trip switches and fuses, and choose appropriate fuse ratings and trip switch settings. Explain what happens when a live wire touches a metal case that is earthed. Explain why the outer casing of an electrical either non-conducting, double insulated, or earthed. Note that a main circuit consists of live wire, a neutral wire, and an earth wire, and explain why a switch must be connected to the live wire for the circuit to be switched off safely. Explain why fuses and circuit breakers are connected into the live wire. Key concept, use of an oscilloscope. Learning objectives. Describes the use of an oscilloscope to describe wavefront. Define how to describe PD and short intervals of time with an oscilloscope using the Y gain and time base. Key concept. 4.5.4.1 Forces on a current-carrying conductor. Learning objectives. Describe experiments to show the forces on a current-carrying conductor in a magnetic field and on a beam of charged particles in a magnetic field, including the effect of reversing A. the current, B. the direction of magnetic field. Recall and use the relative directions of force, magnetic field, and current. Describe the magnetic field patterns between currents in parallel conductors and relate these to the forces on the conductors. Learning objective. Magnetic effect of a current. Describe the pattern and direction of the magnetic field due to currents in straight wires and on solenoids, and state the effect of the magnetic field on changing the magnitude and direction of the current. Describe how the magnetic effect of a current is used in relays and loudspeakers, and give examples of their applications. Key concept, the DC motor. Learning objectives. Note that a current-carrying coil in a magnetic field experiences a turning effect, and that the turning effect is increased by increasing A. the number of turns in a coil, B. the current, C. the strength of magnetic field. Describe the operation of an electric motor, including the action of a split-ring commutator and bushes. 4.5.1 Key concept, electromagnetic induction. Learning objectives. Describe an experiment to demonstrate electromagnetic induction. State that the magnitude of an induced EMF is affected by A. the rate of change of the magnetic field or the rate of cutting off magnetic field lines. B. the number of turns in a coil. State and use the fact that the effect of the current produced by an induced EMF is to oppose the charge producing it, Lenz's law, and describe how this law may be demonstrated. Key concept 4.5.2.1 The AC generator. Describe a simple form of AC generator and the use of slip rings and brushes where needed. Sketch a graph of EMF against time for a simple AC generator and relate the position of the generator coil to these peaks, troughs, and zeros of the EMF. Key concept 4.5.6.1 The transformer. Learning objectives. Describe the structure and explain the principle of operation of a simple iron core transformer. Use the terms primary, secondary, step up, and step down. Recall and use the equation. Vp upon Vs is equals to Np upon Ns, where P and S refer to the primary and secondary. State the advantages of high voltage transmission and explain why power losses in cables are smaller when the voltage is greater. Number 5. Nuclear physics. Key concept. 5.1.1.1 The atom. Learning objectives. Describe the structure of the atom in terms of a positively charged nucleus and negatively charged electrons in the orbit around the nucleus. Describe how alpha particle scattering experiments provide evidence for A. A very small nucleus surrounded mostly by empty space. B. A nucleus containing most of the mass of the atom. C. A nucleus that is charged. 5.1.2.1 The nucleus. Describe the composition of the nucleus in terms of the protons and neutrons. Describe how atoms form positive ions by losing electrons or negative ions by gaining electrons. Define the terms proton number, atomic number Z, and nucleon number, mass number A, and be able to calculate the number of neutrons in the nucleus. Explain the terms nuclide and use a nuclide equation. X to the power A and Z. Explain what is meant by isotope and how one element may have a number of isotopes. Key concept 5.2.2.1 The three types of emission. Key concept. Describe the emission of radiation from a nucleus as spontaneous and random in direction. Describe alpha particles as 2 protons and 2 neutrons, helium nuclei, beta particles as high-speed electrons from the nucleus, and gamma radiation as high-frequency electromagnetic waves. State for alpha particles, beta particles, and gamma radiations. A. Relative ionizing effect. B. Relative penetrating powers. Describe the deflection of alpha particles, beta particles, and gamma radiation in electric fields and magnetic fields. Key concept. Radioactive decay. Learning objectives. Know that radioactive decay is a change in an unstable nucleus that can result in emission of alpha particle, beta particles, and or gamma radiation, and know that these changes are spontaneous and random. Use decay equations using nuclide notation to show the emission of alpha particles, beta particles, and gamma radiation. Key concept. Detection of radioactivity. Learning objectives. Describe the detection of alpha particles using a cloud chamber or spark counter, and the detection of beta particles. B particles or beta particles were taken to refer B- and gamma radiation by using a Geiger-Müller tube and counter. Use count rate measures in counts upon seconds or counts upon minutes. Note what is meant by background radiation. Now the sources that make a significant contribution to background radiation including A. Radon gas in the air, B. Rocks and buildings, C. Food and drink, D. Cosmic rays. Use measurements of background radiation to determine a corrected count rate. Key concept. Half-life. Define the half-life of a particular isotope as the time taken for half of the nuclei of the isotope in any sample to decay. Recall and use this definition in calculations which may involve information in tables or decay curves. Describe the dating of objects by the use of 14C or carbon with the mass number of 14. Describe how the type of radiation emitted and the half-life of the isotope determines which isotope is used for applications including A. Household fire alarms, B. Irradiating food to kill bacteria, D. Measuring and controlling thickness of materials with the choices of radiations used linked to penetration and absorption. Key concept 5.2.4.1 Fission and fusion. Learning objectives. Describe the process of fusion as the formation of a larger nucleus by combining 2 smaller nuclei with the release of energy, and recognize fusion as the energy source for stars. Describe the process of fission where a nucleus such as uranium-235 absorbs a neutron and produces a daughter nuclei and 2 or more neutrons with the release of energy. Explain how the neutrons produced in fission create a chain reaction that is controlled in a nuclear reaction, including the action of coolants, moderators, and control rods. Key concept. Half-life. Explain how the type of radiation emitted and the half-life of the isotope determine which isotope is used for applications including C. Sterilization of equipment using gamma rays, E. Diagnosis and treatment of cancer using gamma rays. Key concept. Safety precautions. State the effects of ionizing radiations on living things including cell death, mutations, and cancer. Explain how radioactive materials are moved, used, and stored in a safe way with reference to A. Reducing exposure time, B. Increasing distance between source and living tissue, C. Use of shield to absorb radiation. Number 6. Space physics. Key concept 6.1.1.1 The Earth. Learning objectives. Know that A. The Earth is a planet that orbits the Sun once in approximately 365 days. B. The orbit of the Earth around the Sun is an eclipse which is approximately circular. C. The Earth rotates on its axis, which is tilted, once in approximately 24 hours. D. It takes approximately 1 month for the Moon to orbit the Earth. E. It takes approximately 500 seconds for light from the Sun to reach Earth. Define the average orbital speed from the equation. V is equals to 2 pi r upon t, where r is the average radius of the orbit and t is the orbital period. Recall and use this equation. Key concept, the solar system. Learning objectives. Describe the solar system as containing A. One star, the Sun. B. The 8 named planets and know their order from the Sun. C. Minor planets that orbit the Sun, including dwarf planets such as Pluto and asteroids in the asteroid belt. D. Moons that orbit the planets. E. Smaller solar system bodies, including comets and natural satellites. Analyze and interpret planetary data about orbital distance, orbital period, density, surface temperature, and uniform gravitational field strength at the planet's surface. Note that the strength of the gravitational field at the surface of the planet depends on the mass of a planet. Around a planet decreases as the distance from the planet increases. Note that the Sun contains most of the mass of the solar system and that the strength of the gravitational field at the surface of the Sun is greater than the surface of the gravitational field at the surface of the planet. Note that the force that keeps an object in orbit around the Sun is the gravitational attraction of the Sun. Note that the strength of the Sun's gravitational field decreases and that the orbital speeds of the planet decrease as the distance from the Sun increases. Key concept, the Sun as a star. Know that the Sun is a star of a medium size, containing mostly of hydrogen and helium, and that it radiates most of its energy in the infrared, visible, and ultraviolet regions of the electromagnetic spectrum. Know that stars are powered by nuclear reactions that release energy, and that stable stars in the nuclear reactions involve the fusion of hydrogen into helium. Stars. State that galaxies each are made up of billions of stars. B. The Sun is a star in the galaxy known as the Milky Way. C. Other stars that make up the Milky Way are way further away from the Earth than the Sun is from the Earth. D. Astronomical distances can be measured in light years, where 1 light year is the distance traveled in a vacuum by light in 1 year. Describe the life cycle of a star. A. A star is formed from interstellar clouds of gas and dust that contain hydrogen. B. A protostar is an interstellar cloud collapsing and increasing in temperature as a result of its internal gravitational attraction. C. A protostar becomes a stable star when the inward force of gravitational attraction is balanced by an outward force due to the high temperature of the star. D. All stars eventually run out of hydrogen as fuel for the nuclear reaction. E. Most stars expand to form red giants, and more massive stars expand to form red supergiants when most of the hydrogen in the center of the star has been converted to helium. F. A red giant from a less massive star forms a planetary nebula with a white dwarf as its center. G. A red supergiant explodes as a supernova, forming a nebula containing hydrogen and new heavier elements, leaving behind a neutron star or a black hole at its center. H. The nebula from a supernova may form new stars with orbiting planets. Key concept, the universe. Learning objectives. Know that the Milky Way is one of many billions of galaxies making up the universe, and that the diameter of a Milky Way is approximately 100,000 light years. Describe redshift as an increase in the observed wavelength of electromagnetic radiation emitted from receding stars and galaxies. Note that the light from stars in all distant galaxies shows redshift, and that the further away the galaxy, the greater the observed redshift, and this faster the galaxy's speed away from Earth. Describe quantitatively how redshift provides evidence for the Big Bang theory. This brings us to the end of the scheme of work of Physics O-Levels 5054.